Hello friend, hope you are doing well. Continuing CCNA lab series, today I will also show some steps config VLAN trunking and spanning tree. First of all, let me introduce topology. Here the four switch, they are connect each other, and I need to configure the VLAN 10 and VLAN 20 on the switch. After that, I need to configure the trunking link between the switch, and the trunking link only allow the VLAN 10 and VLAN 20 and ignore the native VLAN. If you are using the old image, old virtual IOLs, so need change the spanning tree VLAN mode to the rabbit per VLAN spanning tree. In my case, I use the new IOLs image, so I don't need change because rabbit per VLAN spanning tree is the default mode. After that, I configure the spanning tree for VLAN 10 and VLAN 20 using the primary and secondary. That the spanning chain notification on the switch 4 and configure the box 2 is asset box as VLAN 20 and enable BBD Yuga. After that, set the BBD Yuga filter using the user 1 and by the sending the BBD Yuga message to the box 2 on the switch 4. Okay, now let me open the virtual console on the EVE. To open the console in the EVE, just click the virtual device on the GUI, but in the real environment, you need to connect the console cable between your laptop, PC, and console box on the device. Okay, now to go to switch 1, and I need to go to the config mode, and then let me set hot name switch 1, switch 1, and to configure VLAN I need using command VLAN and follow the VLAN ID. The range ID range from 1 to the 4094. Bus VLAN 10 is default VLAN on Cisco switch. Okay, VLAN ID 10 and the name VLAN name cannot include space. If we try space, the switch will inform this the wrong command. Okay, and VLAN 20 and names VLAN 20, and then do so to VLAN bridge, and you see VLAN 10 and VLAN 20 are saved to the VLAN database. Okay, let me set configuration, do right, same like on the switch 2. Go to the config mode and set hot names switch 2 and VLAN 10, name VLAN 10, and then VLAN 20 and VLAN 20. Okay, right, switch 3, go to the config mode, set hot name switch 3 and VLAN 10, name VLAN 10, and then VLAN 20, name VLAN 20. Okay, okay, now switch 4 host switch 4 VLAN 10, name VLAN 10 and VLAN 20, VLAN, and right. Okay, now I need to configure the trunking link between the switch. Let's start with switch 1. I need to go to the interface shop mode box 0 and switch mode trunk. Okay, you see, because the switch support the two the encapsulation type, let me check. So this request me the define the encapsulation cannot config without the encapsulation. chunk encapsulation, you see .1q and ISL, IU.1q, and switchboard mod chunk and switchboard chunk allow VLAN 10 and VLAN 20. Okay, and do run interface 0 to verify. As you know, the native VLANs, because default default native VLAN is a VLAN 1, but in under the zipbox I did not allow VLAN 1. Okay, so I ignore the native VLAN. Okay, and same lines box 1 interface 1 chunk encapsulation 1q and switchboard mod chunk and switchboard chunk allow VLAN 10 and 20 and do run interface 01. Okay, right configuration same like switch 2 interface same box, right? Okay, switchboard chunk encapsulation .1q switchboard chunk allow VLAN 10 and 20 same like box 1. Right, okay, switch 3. Okay, 0 and 1. Okay, and final for switch 4. Okay, right, and to verify the interface chunk using command show interface chunk. Okay, you can see add two box chunk 0 and 1 mod on and encapsulation .1q status native VLAN 1. Okay, same like in switch 1. So interface chunk. Okay, and switch 2. Okay, 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 now I need config the spaghetti for VLAN 10 and VLAN 20 using the primary and secondary. Did you remember in previous video I mentioned we had the two methods to config the spaghetti using the priority and then primary and secondary keyword. Cisco recommend using primary and secondary keyword to config the spaghetti. Okay, with VLAN 10, I want to switch one is a root switch and secondary root switch is the switch 2. Okay, so let me show the command. Okay, using spaghetti VLAN VLAN ID root secondary or primary. Okay, switch 1 config terminal spaghetti VLAN 10, sorry, VLAN 10 and root. Switch 1 is a primary, so using key primary key, and switch 2 is secondary root switch, so spaghetti VLAN 10 root secondary. Okay, and we don't need to do anything in switch 3 and switch 4. Okay, now so do so spaghetti VLAN 10. Okay, you see this bridge is a root. It means the switch 1 is the root switch of VLAN 10. Head priority is the 24586 because when we use primary keyword on the switch will pick up this primary for the pick up this value for primary priority value, and then plot the VLAN 10. So the total priority is the 586, right? Okay. You can see the MAC arrest as because this is a virtual device, so I don't have the MAC arrest of physical MAC arrest. This is MAC arrest of box. Should we use the box has the lowest MAC arrest? Let me check by show uh, interface 0. You see MAC arrest of box 0 1000. Okay, correct. In the real environment, switch is the physical device, so switch has the MAC arrest. Okay, so don't confuse this point. Okay. Now, let me show in the CCNA VLAN 10 on switch 2. You see this binary of switch 1, MAC arrest of switch 1. Got did you remember in the previous video I mentioned we had the two method of got short and short got and the long short method and the long method. Because in the virtual environment should use short method and the speed of box is 1 megabit per second, so the code of box is 100. Okay. And bridge ID is bridge ID of switch 2 primary priority. This value the default is 672 1 because when we use the secondary keyword should we pick up this value and plot the system ID extension 10, so we had this priority set A2. Okay. The timer, hello timer, mark A and forward delay is the default. I did not change. Okay, how about the switch 3 and switch 4? So it's energy, VLAN 10. Okay, VLAN 10 have bridge ID, default variety, and blood system ID extension. And on board of switch 3 is forward status. And how about the switch 4? Switch 4, so run. So energy VLAN 10. Okay, so switch 4 same except the box 1 is box 4 box 0 is alternate box blocking status. This reason why is link between the switch 3 and switch 4 the designated box and will use the root barcode of root box, right? So we can see box 0 on the switch 3 connect to the root switch, so this is the root box. And on the switch 4 box 1 and box 0 has same the root barcode, right? 100 and 100 and 100 total is 200, right? So switch 2 will compare the brick ID of switch 2 and switch 3. Switch 2 had lower priority, lower and then box 1 is a root box on the switch 4. Okay, so box 0 box 1 on the switch 3 and box 0 on the switch 4 will do the election designated box election. Box 0 on the switch 3 has the root barcode is 100, right? So box 1 on the switch 4 has a root barcode is 200. So box 1 on the switch 3 is designated box and box 0 on the switch 4 is the root is a alternate box and blocking state. Even the switch 2 is a secondary it doesn't matter. Okay. Okay. Now let me configure binary for VLAN 20. Switch 2 is a root switch and switch 1 is a secondary. Same right. Okay, binary VLAN 20. Root switch 1 is second. Okay, and switch 2 binary 10. Sorry, 20. Root 20 root priority. And do so binary VLAN 20 and this one will pick up the value this one 576 and below 20, so priority is 596. Okay, and how about this 4? So so 70 VLAN 20. Okay, 1 pick up these values and below 20, so total is 6 and 92, right? Okay, now the switch 3 we had one alternate box, so spend 20 VLAN 20 box 1, correct, right? Same the logical in the VLAN 10. Okay, and switch on box on the switch 4 is forward 20. Okay, correct. Okay, now let me show Serenity background method using in the switch method. Okay, using sort, right? So the code is 100. Same like in switch 4. So Serenity background method. Okay, sort method. Okay. Now I will configure box 2 on switch 4 asset VLAN 20 and testing the PPDU filter. Okay, go to switch 4 and go to configure mode and interface shop mode box 2 and using the switch box mods access command and switch box asset VLAN 20 and do so run interface 2 to verify, correct, right? Okay. Okay, and now I will go to the user 1, this is line of user, and try send BBD Yuga. But let me enable the BBD Yuga in the interface. Do you remember we had the two method to enable BBD Yuga, right? One under the configure mode and second is under interface, because I had the one only one that access a box, so I will enable this feature under the interface with Yuga and then enable. Okay, so now let me skill share to the user 1 and send some BBDU message to the box 2 on C4. Okay, my line of user is 20, 10 and 143. Okay. Okay, and to send the BBDU message, I use Scapy library. It's really helpful, really famous. Okay, sudo Scapy. I installed already for save time. Need to run Scapy using the root permission. Okay, and using this command, send walk and doc3 destination MAC address and source MAC address. Source MAC address is a MAC address of box on box 0 box. We will send the BBDU message, and then destination is severity multicast MAC address 000000, and some the setting for the layer 2 parameter and interface interface to send out the BPDU message and count to. I will send the two BPDU messages to switch 4. Okay, and let me okay and okay, and now the switch 4 will inform the error receivable BPDU error detect on the box 2. Put the box 2 in the error receivable state and box down, and let me show interface status, and we see the box 2 now status is the error receivable. Okay, to recovery box, we just go to the box 2 and then shut down box and wait a few seconds and then no shutdown. After that, box will recovery. Okay, and do so interface status. Now box is recovery. Okay. I think we are working well, right? The final task is test the spelling tree chain notification. Let me enable the spelling tree event on the sheet 4 using the debug command. Debug spelling tree event command, and then I will set down the box 0 select 1 on the sheet 4 and check the message debug message. Okay, let me show the spelling tree VLAN 10. Okay, box 10 box 1 is root box and VLAN 20 also box 1 is root box also. Okay, now interface 1 and shut down, and you see when I shut down box 1, spelling tree wireless box is down, and then I start the topology chain for VLAN 20, VLAN 10 and VLAN 20 also. Okay, after that, waiting a timer expire and then push the box 0 to the root box. Let me check. Okay, yes, box 20 now. Box is root box for VLAN 20 and VLAN 10 also. Box 02 also to calculate one more time because it also belong to VLAN 20. Okay, and now I no shutdown box 70 topology will start again. Okay, when the box up the sprinty initializing the box 1 and box 1 now come back to the sanity box. Okay, and for VLAN 10 and VLAN 20 also, and then after that box 0 now back to the block box. Okay, so you see when the physical box change, the VLAN on the trunk box will be recalculate spelling tree, so it's not good situation. Because if you we had a lot of VLAN, this effect to the user working and also the switch operation. So to resolve this problem, the multiple spelling tree will use multiple spelling tree will gathering the VLAN into the instance and so limit the spelling tree topology chains. Okay. Okay. I think conflict VLAN trunking and spelling tree is not complex too much, and in bracket, I believe this topology will not use and should be enough. And Cisco has some technology to extend the switch without the spelling tree. Example the stack Y or visual stack. So thank you for watching, and see you in next video. I hope get your like and your subscribe my channel, friend. Bye bye.